I would like to thank you, IPCC, for inviting me. And I would also want to say thank you for everybody here present. See, I would like to present here a technology, innovative technology role in pollution reduction. See, pollution is not just an environmental issue, it's a developmental issue. Why? India is observing a rapid industrial growth and urbanization. When you take a rapid growth, there will be a effect on the environment by many means. Apart from that, we have a historic pollutants present as a dump sites, and also we have this emerging pollutants challenging the environment. And all this will creating the pollution of the water, soil, air, and ultimately it is affecting the food chain. And also it is affecting the human beings. These all issues going to put the global sustainable goals in a risk, certain goals. Yes, please. Okay, thank you. To meet this both development and sustainability goals, we must shift from the reactive cleanup or reactive action to the proactive innovations. And that where green tech and sustainable and bio-based technology play a game changer role. See, sustainability can be achieved through this innovation. Innovation can be development of solutions based on the biological tools or AI tools, and focusing this certain solving the focus problems. You can address the industrial problems and agricultural pollution, targeting the pollution faced by the industries. And this technology has to have an impact, development, success in pilot projects and field projects, and it has to be a tangible benefits that has to be ultimately reduce the pollution, and it has to be a scalable. When you make any technology, it has to be scalable, transition from the local trials to the regional, and it has to go to the national implementation. That could be possible only when we have a required policy support and funding and public-private partnerships. And this sustainability is possible only through the long-term integration into industrial practices. See, this innovation always act as a catalyst for a sustainable industrial pollution reduction. Because when you go for the conventional approach, you have a remediation, we do the remediation after damage, or we go for a chemical treatment with a heavy cost investment, and it will be uniform application, and it will be a resource incentive. Whereas it is an innovative approach, we are going to target only preventive measure we are going to take, and it will be a real-time prevention. Well, and it will use the bio-based technologies, AI-based technologies, and this will be targeted, and it will be smart application, and it also a data-driven. You have to collect data, and based on that you have to act. And coming in these all innovation would be as efficient, and it would be a low carbon emission also. Since I am representing from the research institute, we are into the green technologies, and we have different sectors. Basically, I would like to address bio-based technologies. We have two divisions that we are working on the bio-based technologies. Industrial biotechnology, it has developed different technologies like algebra technology and biopolymer products and microbial enhanced oil recovery and bio-based coal bed methane. And apart from that, sustainable agriculture division is that they are working on this biofertilizer development and nano-fertilizer development. I would like to here present to a couple of the technologies which have an impact and which has helped to reduce the pollution. One would be the bioremediation of the oil contaminated sites through the microbial consortia, that is called the algebra technology. And second would be the nano-enabled fertilizer that has helped to reduce the agrochemical runoff and heavy usage of the chemicals. And it enhances the nutrient efficiency also. This ultimately helps to achieve the certain SDGs. Coming to the algebra technology, this is also reducing the emission and also it is helping to eliminate the hazardous waste. Algebra technology, as I mentioned, we are using this to manage the hazardous waste and remediate the hazardous waste sites. This is basically a bio-based technology where we are using the live microorganisms, and it is used for the hazardous waste management, especially from the oil industries, pesticide industry. We have actually here taken the microbes from the nature, different microbes attacking the different component of the pollutants. So this technology is very easy. It is a fermentation-based technology. It can be produced in a very short time, and it can be very easy to apply also. We are producing it in liquid form, converting it to the powder, and that is very easy to transport and apply in the field. This technology has been used for the treatment of the oil contaminated sites and other hazardous waste managements. And this is the site we can see after and before using the algebra technology. And this is a massive hazardous waste neutralization you can see here. And it is also helping in the reduction of GHG emissions and also soil restoration and reuse. And this also reduces the water pollution. And also, when you compare this technology with other traditional technology like incineration, if you see incineration, there would be a high GHG emissions and energy use. And compared to landfilling also, there will be high GHG emissions and low energy use. Similarly, chemical is also there. When you use this technology, you will find a low carbon footprint. So it is a very environmental friendly technology. Apart from that, we have also developed one technology based on this biogenic nanofertilizer. If you see, agriculture sector also is one of the sector where it is polluting the most of the soil and water. If you use this biogenic nanofertilizer, it will be very good for this soil health, and it will also reduce the water pollution. See, sustainable alternatives, it can be used as a sustainable alternatives for these chemical fertilizers. Since nano means they are having a high surface area to volume ratio, it's very easy to handle also. And it improves the solubility and availability of the nutrients. And it also better nutrient uptake efficiency also it is shown by the nanofertilizers. It's control the nutrient release, and also it reduces the loss of rate of fertilization through the leaching. These are the few products developed by the TERI. They are nano urea, nano DAP, and nano phosphorus. And these are very lower input, you can go for this, and it will be lower emission also. Since we are using a biogenic process, there will be less emission, and also it is reduces the leaching. When you go for a traditional synthetic application of the fertilizer, it will be always leached to the rainwaters, and when it is also less energy in production and transport also. And this there will be, when you use in nano form, there will be high nutrient uptake efficiency would be there. That will be up to 90-95 as compared to the synthetic. When you are using the synthetic fertilizer, it will be usage efficiency would be up to the 50% only. In certain chemicals, it is only 20% also. It's like phosphorus fertilizers. This technology has been already developed, and we are in the process of transferring technology to the few companies. If you compare the conventional and nano-enabled agriculture, see, nano-enabled agriculture would be what it will be. We have to deliver on the targeted one, and it will be based on the AI sensor. Wherever there is requirement, that only you have to apply there. And also, it enhances the utility of the nutrients. If you compare the technology impact, this algebra technology will be helping in the crude oil and hydrocarbon contamination elimination. It has used it has used to treat the several contaminated sites and restored across the India and globally. And this biogenic nanofertilizers, this is been reduced to use a conventional fertilizer by more than 25 to 50%. Suppose in DAP there will be a lot of 30% reduction is there, and different micronutrients, their reduction of this synthetic fertilizer you can use. I just don't want to go about this biotechnology market and all the things. Coming to the scaling of this sustainable industrial pollution control, there should be a call of action. What you require is collaboration. Usually there is a need to be collaboration between the industry, academia, and policymakers. And that collaboration has to adopt the green and sustainable technologies. And there need to be invest from already proactively industries are investing. Still there is a need for investment. And also there has to be a national initiative. Like nowadays, even the government is also taking a national initiative also. Like DBT is taking a BIO3, that is also for the product development only. And there has to be a support for a translation. There has to be a fast track TRL progress. Through that we can achieve the innovation grants, and industry has to be tie up for this implementation of this innovation technology to take into from lab to the field. And also there is a need to educate the stakeholders, end users, all this is required. Just I want to conclude. Technology is a powerful enabler to mitigate the pollution, and innovation approaches are from bio-based to AI-driven, monitoring or transferring the way of pollution is detected and managed and reduced. And collaboration between science, industry, and policy is essential to accelerate the adaptation of them and maximum impact. Thank you.